Okay, so we've gone over our learning objectives. Let's look at parameterizing plane curves. Okay, so it's very easy. We've looked at before in Calculus 1 and Calculus 2, equations of curves, so we can recall curves. We have y can be a function of x, or we may even have x as a function of y. But however we put it, we can take both of these and we can transform both of these into something that looks like some function f of x and y is equal to 0. All right, so we can do that. All right, so we want to have a parametric equation. So a parametric equation requires a parameter. So a parametric equation, we get a parameter t. All right, so the motion of a point traveling a trajectory is described by giving its position all right, as a function of t. Okay, so here's, I have a curve. And this point right here is the point XY. All right, just like before. Just like before. Okay, so now what we want to do though is we want to say that this X, the way you get to the X is you have to know some function of T. And the way to get to Y, you have to know what the function of T is, and you have to know T. All right. So script C, all right, let me draw it again. That looks crazy. Script C, all right, this is the graph of a parametric curve. Okay, so there are a couple of things that I need to tell you. All right, you end up with X of T, comma, Y of T, describes your point, and then you get information about T, and that gives you your curve. Okay, so here's the first example. So example 1, let's say we have X is 2t minus 3, and Y is 4t minus 1. So this is X of T, and this piece is Y of T. So now I know what they are. So I'm asked to sketch the curve. Now I can sketch this curve several different ways. Okay. One way I can do it is I could figure out what the Cartesian equation is. So I can find the Cartesian equation. Not always easy, but we can do it with this one. EQN is equation. So that means I want to solve for t. So I have x is 2t minus 3. So therefore, when I solve for t, I'm going to get x plus 3 is 2t. So t becomes 1/2 x plus 3. But now I'm going to take that and put that into my y. So y is 4. Well, here's what t is. So I'm going to get 4 times 1/2 times x plus 3. And when I'm done, I simply get 2x plus 5. Okay, so my Cartesian form is y is equal to 2x plus 5. So now that's easy to graph. Okay, the reason why that's easy to graph is because when x is equal to 0, that simply means that y is equal to 5. And when y is equal to 0, I get x is equal to minus 5/2. So I get the 0.05.
Wait, excuse me.
Yes.
Can you hear me? So
Yes.
how did you get the 5? I thought it would be 6 because 3/2 is times 4 would be 12/2, not 5. You see it? Or I'm tripping.
Because I forgot the -1. Where
Oh,
was
okay.
y?
Okay.
Where was y?
All right, thank you.
Y is 14 minus 1. Thank you.
Oh, okay, I'm sorry. I didn't see the minus.
Nope, you're good. I forgot it. -1. That's important. Now I get 2x plus 5. You are so correct. Thank you. All right. Okay. So 0, 5 and -5 have 0. And then I can draw a line through it. Okay. All right. And so there is the graph. So we have two different things. So there are two ways to define this curve. Okay, so here's the curve. So we have y is equal to 2x plus 5. And clearly, minus infinity is less than x is less than infinity. Or I could define it as x of t is equal to 2t minus 3. Y of t is equal to 4t minus 1. And minus infinity is less than t is less than positive infinity. Okay, so those are two ways to define that same curve. Okay. So we want to have a definition. A parametric curve C in the plane is a pair of functions x equal to f of t and y equal to g of t that give x and y as functions of t. In an interval I. So I have to tell you what t is, where t is. Okay. All right. So say we have parametric equations. X equal to f of t, y equal to g of t, and then t is an element of AB. So this AB is my interval. Okay. Where this thing AB is closed. All right, then, now this is going to look weird, but I'm going to write it as P of A. That's the point that's defined by F of A, G of A. And P of B, that's the point that's defined by F of B, G of B are the endpoints. Okay. So here's an example. So I have X is equal to cosine of T, Y is equal to the sine of T, and T is an element of 0, pi over 2. Okay, well, that curve, all right, I'll show you why it is later, but for now, that looks like this. So that's the semicircle that goes like that. This point is PA, okay? It is F of 0, G of 0, all right? So if I put in 0, I get the cosine of 0 is 1. I put in 0, the sine of 0 is 0. Then this other point, PB, is the other endpoint. I put in pi over 2. The cosine of pi over 2 is 0. The sine of pi over 2 is pi, is 1. Now here's the fun thing. How do I know that the curve is going in this direction? We'll talk about that in a minute. Okay. All right, so now you know what it means for the curve to have endpoints. Definition: if PA is equal to PB, then the curve is closed. So if I took this and went all the way around and came back, then the curve would be closed. So P of A is equal to P of B, we have a closed curve. All right, another definition. Got my N up here. Okay, if C does not intersect itself, then C is simple. Okay. Okay, so that's a simple curve. Not simple. This is a simple closed curve. And this is a closed curve that's not simple. So this is simple, not simple. This is simple closed, not simple closed. Okay, any questions about that? Okay. All right, determine the graph of the curve x equals 2 cosine t y equals 2 sine t, 0 less than equal to t less than equal to 2 pi. All right, well, there's two ways I can do this. All right, the first way is the long way, and that is to actually just graph it, starting off with t is equal to 0. So if t is equal to 0, all right, the cosine of 0 is 1, multiply it by 2, I get 2. The sine of 0 is 0, multiply it by 2, I get 0. So it starts at the point 2, 0. And then let's go to pi over 4. I'm sorry, pi over 4. So the cosine of pi over 4 is the root of 2 over 2. So when I multiply it by 2, I get the root of 2. And then I'm going to get the root of 2 here. And so the next place is going to give me the root of 2, root of 2. So this length is 2, and I am exactly 45 degrees away. Then I'll go out root of 2 distance. If I go to pi over 2, cosine of pi over 2 is 0, multiply it by 0, multiply it by 2, I get 0. And then here, I'm going to get 1. So as you can see, now you can see why I knew that I was tracing out the curve in a particular direction, because I'm tracing out the curve as t increases. And this one is going to keep going. I'm going to get, that's kind of really ugly, but should be a little smoother than that. Here we go. And this thing is going to trace out a circle of radius 2. So each point that I'm choosing to check, so as I'm doing this, I'm going in this direction and I'm going counterclockwise. And so it actually matters the direction. So direction matters. If I switch X and Y, that's a whole nother curve. Okay, so these points lie on a circle of radius 2. I can keep going until I get down to 2 pi. And then this is 2 and 0. So I can see this is not only a simple curve that's a circle, it's also closed. Okay, now suppose I wanted to try to find the equation in XY coordinates. So find the Cartesian representative. So let's go back and just call this C. So let's find the Cartesian form of C. All right, well, that's not too hard. We can always use the fact, always throughout this course, we can always use the fact that the sine squared of something plus the cosine squared of t will always equal 1. So let's use that. So we're going to solve for sine of t and cosine of t. So from x is equal to 2 cosine t, we're going to get that the cosine of t is x over 2. And from y equal to cosine equal 2 sine t, we're going to get the sine of t is equal to y over 2. Aha, so the cosine squared plus the sine squared of t is going to be x over 2 squared plus y over 2 squared. And I already know that equals 1. Hence, I get x squared over 4 plus y squared over 4 is equal to 1, or x squared plus y squared is equal to 2 squared. So this is a circle of radius 2, r equals 2, and my center is 0, 0. So I started with just a very basic parametric equation for the curve. Then I did the long way. I said, let t equal 0 and find out what it does all the way around. And I was able to trace this thing going counterclockwise all the way around. But then I said, okay, I did that. Let's find the Cartesian form. So I now need to eliminate t. So the way to eliminate t, when you've seen sines and cosines, if you see them, then you solve for cosine squared and sine squared. And so now we can see that we get a circle of radius 2. All right, let's see, I have 5 more minutes. So let's see here. All right, so we said that direction matters. Okay, so we know direction matters. All right, so let's try something else. Let's try x equals cosine of t. We already said x equals cosine t, y. Okay, x equals cosine t. Y is equal to sine t. 0 less than t, less than or equal to t, less than or equal to 2 pi. So this is my curve. All right, so just from what we had before, I should know now that this one is going to be a circle of radius 1. Because when I do that, I get cosine squared, which is x squared, plus sine squared, which is y squared, is equal to 1. So that's nice and simple. Let's try something a little bit more difficult. Okay, so here's my curve. X of t is going to equal 1 minus t squared divided by 1 plus t squared. And y of t is going to equal 2t divided by 1 plus t squared. Okay, well, again, oh, I need to tell you t. T is minus infinity less than t less than positive infinity. Okay, so that looks kind of weird. But let's say, let's try this again. So let's again try x squared plus y squared and see what we get. So x squared is 1 minus t squared over 1 plus t squared. And y squared is simply going to be 4t squared over 1 plus t squared. Squared. So x squared, let's see, x squared turns out to be 1 minus 2t squared plus t to the fourth divided by 1 plus t squared squared. And y squared is exactly what it is. So let's add them together. So x squared plus y squared is 1 minus 2t squared plus t to the fourth plus 4t squared over 1 plus t squared squared. But in the top, I get 1 plus 2t squared plus t to the fourth over 1 plus t squared squared. But guess what? That's what the top is. It's 1 plus t squared squared over 1 plus t squared squared. Aha. So now I get x squared plus y squared is equal to 1. So again, I get a circle of radius 1. But here's the thing. The way this is parameterized, and this is not something you would know unless I told you this. I would have to tell you this for this problem. So don't go, oh my God, how am I supposed to figure this out? I would have to tell you this for this problem. Okay, this is also a circle of radius 1, but when t is 0, it's here. So this is where it is when t is 0. And as t becomes more and more negative, it travels this way. And as t becomes more and more positive, it travels this way. But the problem is, t goes to infinity and never stops, and minus infinity. So this thing gets all the way over here, and there's actually a hole. So even though this looks like a circle, this is not the same parameterization as the other one. Okay, so these give you two completely different parameterizations. Okay, so tomorrow, I see y'all tomorrow. So tomorrow we're going to look at some other simple plane curves and then talk about how to do area, surface area, lengths of curves, and that kind of stuff using it, okay? Any questions?